My name is Leo Lorenz. My professional background is power semiconductor technologies. This is including devices, packaging technology, and the application of the power devices. Basically, I have a long history in this field, more than 40 years, working for Siemens and later on for Infineon Technologies. For the paper evaluation, we have 3 criteria. The first criteria, we are having a look on the contents of the paper, whether it fits to the scope of the PCIM conference. The second one is the innovation level. We want to see what is the innovation of the paper. And the third one, we are having a look on the outcome, on the results, and basically as PCIM is a more application-oriented conference, we want to see the theory, the simulation, and also the application. We want to see demonstrate the project. I would categorize this in 3 levels. We have on the first level the components. These are power semiconductor devices, and here lots of new development is happening for silicon-based devices as well as for wide bandgap-based devices. Then we have several excellent papers for passive components like new ferrites and new capacitors. The second level is the level for packaging technology. Here we have several excellent presentations about the scalable power electronic building block. This is also including sensors and the driving of the power module. And the third one is more on the system level. Here we are talking about the basically more high power application in the electromobility and also application on the energy topic. So very high power, but also when we have several excellent papers on power density, so the future is going towards higher power densities on the converter level, higher efficiency ratings, and also digital control. Well, we all know there are many conferences around the globe. The unique characteristic of the PCIM is that we have a very strong exhibition. The companies coming, they are displaying their new technology, and they have experts on the exhibition floor. So you can go there, you can see the technology, and you can talk to the experts on the conference floor. We are having usually papers showing the future direction of power electronics, also new research results in the field of power electronics. And also there is an open dialogue between the experts giving the presentations and the audience attending the conference. Yes, I see many benefits, especially for AI, but also IoT and the 5G. AI is helping us a lot in order to be faster on the market, to reduce the development time, and also to have a higher yield in the production. So basically we apply AI in the vertical direction from the component sourcing up to the cloud, and in the horizontal direction from the product idea to the product development, the production of the power converter, the application of the power converter, and finally also the process running on the output. On all of these levels, we have benefits using AI. The challenging point is today that AI is not an industry standard. And for this reason, always we have to ask the question, how reliable are the data we are generating and we are processing? In terms of 5G, I see at the moment a niche application. This is for very dedicated motor control. For example, in paper mills, when there are many motors working together and you have to control the torque and the speed of the motor very, very precisely. In this case, 5G might help us, but this is up to now in power electronics a niche application. Basically, when we talk about the global development of power electronics, then we have 5 levels. We have the level 1, this is the component level. Here we have, of course, new developments and new trends for the wide bandgap technology. This is a very strong driver. Then we have, on the passive components, a new development going on, new ferrites, new electrolytes. This is very important for us because when we want to utilize the benefits of the wide bandgap devices, we need to come up with new devices for passive components. The second level is the level for packaging and interfacing technology. I mentioned this already before. Here we have to go new ways. The chips are getting smaller. It's more demanding to take care about the heat transfer. The chips are switching faster. We have to design the modules in the right way. We have to manage all the parasitics on the module level, and also the smart, scalable power electronic building block to integrate sensors, integrate digital control circuits in order to have a very compact and a power module usable in all applications. Then the third level, this is the application system level. Here again we have 3 main directions. One direction is for electromobility. The other direction is for the energy sector, renewable energy technology, solar power, wind power, energy storage, but also the grid concepts. And the third one are the data center. And now the fourth category, this is AI. I mentioned this already. We have many benefits by using AI in the application. However, we are in the very beginning. We have to generate the industry standard first in order to have reliable data sets in the application. And the number 5, and this is also very important one in the future, this is what I call design for sustainability. We have to look on the CO2 footprint of the components and the systems. We all know we have to meet net zero CO2 emission in 2050 or 2060 here in China, and for this reason the life cycle analysis and also the CO2 footprint is very important.